All right. So in today's class, we had a discussion of differentiation and its application in this manner, right? We'll be continuing it further. We also understood about application of integration, right? Where we understood that how do you calculate the mean or average value. Then we understood the parallax method, right? S is equal to R theta is one of the formulas. And we also understood the relation between degrees and radians, degrees and minutes, degrees, minutes and seconds, right? Which can help you in interconversions. Then in today's practice class, we understood about how different sine theta, cos theta and tan theta values can be calculated by interconversions. We also understood how do you apply the concept of integration by drawing a graph and finding out area under the curve, right? Then we also understood initially that integration has different ways of understanding it. One of the most important ways to think of integration as just the opposite of differentiation. If you differentiate something and get cos x, it means when you integrate cos x, you should again get that something, right? Now, area under the curve is how the second application of integration is concerned with. Integration is of two types, definite and indefinite integration. Then we also understood that differentiation can be, differentiation is a concept here we understood, which can imply the slope of the tangent, right? Slope of the tangent. This question which I gave is for you all to solve, where y is given as x square plus x cube minus 3, and you're supposed to find out the slope of this curve at x is equal to 1, right? Now another way of understanding differentiation was delta y by delta x, right? The slope of the graph such that delta x is very, very small, right? Or even one more way of understanding this was taking dy by dx as tan theta, where what is theta? Theta is the angle which this line or the tangent makes with x-axis, right? This is theta. So this is how we understood different concepts in today's class. Right? One of the final and one of the most important concepts in differentiation is, have a look here. I had told you all today morning that we have something called as first differential, which is called as dy by dx. First differential, right? Or first derivative. It is also called as first derivative. There is something called as second derivative, that is d2y by dx square. I'll try rotating it over. So you have two kinds of derivatives. I will repeat. One is called as first derivative, dy by dx. The second is called as second derivative, written as d2y by dx square. This is also written as d by dx of dy by dx, right? And we have already come to a knowledge or understanding that dy by dx is nothing but the slope, right? So when I'm writing d by dx of slope, I mean d by dx of, or dy by dx, when I'm writing d by dx of dy by dx, I mean d by dx of slope, right? And we have also defined differentiation today morning as rate of change of one quantity with respect to another. So this is the fourth definition, rate of change, right, of one quantity with respect to another. So the application of which we all will be seeing in the tomorrow's class, where we'll be understanding in detail the other or the most important concepts in kinematics, right? So you have, let's say there is a concept called, or a term called, velocity. Now we define velocity as rate of change of displacement. Rate of change of displacement, right? So how do you write this? As v given as dx by dt. This is the key point. So how are we merging from mathematics to physics? A very, very crucial point of understanding, that until now we were just talking about rate of change. Now I am talking about the rate of change of displacement. That is how displacement of the body is happening in consideration of time. Let's say a body was somewhere over here. After some time, it got displaced to some other time, to some other point. So when I'm seeing that, what do I mean? I mean that, let's say this body was at x is equal to 0. It went to another point, x is equal to 5, right? So I'll also have to specify in how much time did this phenomena happen. Suppose we started measuring from a point t is equal to 0, and then we stopped measuring at a point, at a time t is equal to 10 seconds. So this is how we are talking about displacement with regard to time. And therefore we say or define a term called as velocity, which is nothing but a rate of change of displacement with time, right? All right, so this is what, how we connect rate of change with velocity and some other variables. Before we go ahead, I will tell you one important point, right? So as I just defined, d by dx, right, is nothing but rate of change. So d2y by dx, or the second derivative also would mean rate of change of slope, right? Rate of change of slope. So just have a look here. Initially, I'll name these points. Let's say this point was A, this is B, this is C, this one is D, this one is E, this one is F, right? So have a look. As I'm going from the point A to B to C, what is happening to the slope? What is happening to the slope? So can any one of you answer me? Let us take the answer from Monica. Monica, can you tell me what is the slope at A? Is it? I've written it in green. Just read it out. Yes. Monica, are you there in the class? Yes.
Yes, sir, I am there.
Yeah. So we have what is the slope at A? It is positive, right?
Oh, in the graph, yes, positive.
Yeah. At B it is.
0.
At C it is
Negative.
negative. So what is happening to the slope, Monica? Is the slope becoming, is it increasing or is it decreasing?
Decreasing.
Any quantity which is initially positive, then becoming 0, and then negative is actually decreasing. Absolutely correct.
Decreasing.
Right. So as we go from A to B to C, the slope is decreasing. That means, what does this imply? It implies that the rate of change of slope with respect to x is negative, right?
Yes.
And what is this point called? This point is called as where y achieves its maximum value locally, is called as local maxima, or it's just called as maxima, right?
Yes.
So what can we conclude from this? That at maxima, what is happening? The,
The slope becomes 0.
yes, the d2y by dx square is negative, and the slope, that is dy by dx, is 0.
0.
Right, Monica? Correct?
Yes, yes, sir.
Now, tell me, is it not the just other way around when you talk about the transition from D to E to F? See what is happening. Tell to the class when we are at D, right? So I'll rub this one point from here. And since the class is easily available to all of you, so in case during the time of the class you miss out on some notes, so by the end of the day you can always log on and like to physics.fatnani, and from there you can watch the video, pause at the point where you are not written the notes and copy them down, no worries. So Monica, let's continue. When you go from D to E to F, tell me how is the slope getting changed? Initially at D the slope is
Negative.
negative. Then the slope at E is equal to
0.
0. Why is it 0?
Because the tangent of the line is
Parallel to
the x-axis.
axis. Absolutely correct. Absolutely correct, Monica. Yes. How about the point at F here?
It is positive.
Positive. So what can we conclude about the slope? Is it increasing?
Positive slope.
Increasing.
Yeah, it is increasing.
It is increasing. Absolutely correct. So if the slope is increasing, then the rate of change of slope or d by dx of slope should be positive or negative?
Positive.
Absolutely correct. Absolutely correct, Monica. So what can we conclude? That, acha, at this point, tell me what is your observation? At this point, what is your observation? Here, y is maximum or minimum? Minimum, right?
Yeah.
So this point at the top, point number B was called as maxima, whereas
Maxima.
point number E or point E is called as minima,
Minima.
right? Now,
Yeah.
I can say that at minima, we have dy by dx. dy by dx is equal to 0,
0.
right? That because the slope of the tangent was 0, so dy by dx is 0 at both, at
Yeah.
maxima as well as at minima. Dy by dx is 0. But what about dy
0.
by dx square at minima? At minima
It is positive.
is positive. Why? Because the rate of change of slope is positive,
Positive.
right? And the same rate of change of slope is nothing but the second derivative, or
d2y by dx square.
y by dx square. Absolutely correct. Absolutely correct, right? So this is something really appreciable if you all have understood. Monica, are you very clear with this fact?
Yes, sir.
Right. So I'll write it down here very clearly for the sake of convenience of everybody. Let's say this is y-axis, this is x-axis. We have this as y, this as x, right? We have a curve here this way, which is taking its maximum value and then taking its minimum value. So at this point, when the curve is attaining its maximum value, we call this point as maxima. And at this point, we just found out that dy by dx is 0 because the slope is 0, and d2y by dx square is negative. Very important. We have here at this point dy by dx, this is at minima, dy by dx is equal to 0 and d2y by dx square is positive, right? This is minimum value of y. These are also called as local maxima and local minima. You have several questions coming up which we'll practice in tomorrow's class, which are based on this concept, right? They'll be from the past year JEE and past year NEET questions, and I am very sure you're going to love solving this only when you are clear with this concept. Very important, you should be clear with this concept. So I'll give you one homework. I'll leave you all with one homework. First, I'll solve one such question. Let's say you are given with y, right? Y is equal to sine theta plus root 3 cos theta, right? You're given some expression like this. You're being told find y maximum, right? So how will you solve such a question? So in order to solve this question, or let's do this as a short assignment which we'll be discussing in tomorrow morning's class, right? Let's not extend this class anymore. So tomorrow morning, when we start the class, before understanding other concepts of kinematics, we'll have a short discussion about such questions where you will be having such given value of y, and you'll be supposed to find out the y maximum and y minimum, or for what value of find for what value of theta for which the y is maximum or minimum, right? It's up to you. You have to tell me whether what you are getting is maximum value of y or minimum value of y, right? So this is what I wanted to highlight, right? What is the question? You have to find out what is y maximum and y minimum, and you have to find out theta for which y is attaining that maximum or minimum value. I'll give you a hint. The hint is just nothing but what is written on the left hand side of the screen, for which for this question you will require some formulas like d by d theta of sine theta, right? Or d by d theta of cos theta, for which you will be utilizing the formulas which I have sent you all on the chat, like on the chat, right? So please use those formulas and try solving this question. In case you are not able to, or you are able to, doesn't matter, we are definitely going to discuss this tomorrow morning. In case I forget, please remind me, right? So this is how we are concluding today's class. In case anybody has any queries, please remind me in tomorrow's evening class, and you can also put me a message so that I'll have that in my memory and we'll take it up, right? So thank you everyone. Let's meet tomorrow morning at 8:50. Do make sure whatever we have read today, do revise, and any queries, I am there. Right. Thank you very much, class. Thank you so much.
Thank you, sir.
Thanks a lot. Thanks.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.